let's look at this differential equation and just ask yourself, if I were solving this, what type of function would the solution be? So pause the video and actually think about that. What type of function would solve this? All right, if you said exponential, you would be right on the money. Absolutely. We know that exponential functions, right, particularly y equals e to the x, we know that the derivative of e to the x is e to the x. That's what's so remarkable about e to the x, that at a specific y value, let's say this is a y value of 7, when the y value is 7, the rate of change, the slope right there, is also 7. That is what's so wild about e to the x. So I think it makes sense. What this differential equation really is saying is my rate of change, my derivative, is proportional, we're assuming k is a constant of proportion, to the y value. So we know the function that solves this is going to be an exponential function. Shall we solve it just to see what it's going to look like? Let's do that. All right, so of course y prime is really dy dx. This certainly looks separable. I'm going to divide by y. And it doesn't really matter where the k goes. I'm just going to leave it over here so the dx isn't lonely. All right, I'm going to take the integral of both sides. This will give me the natural log of the absolute value of y. Taking the antiderivative of k with respect to x, so that's the constant times x plus some other constant. Those that k and that c are obviously different constants. Remember, we have a little invisible e there. I'm going to rewrite this in exponential form, so it's e raised to this whole brouhaha equals the absolute value of y. We've been doing this quite a bit, rewriting this as e to the kx times e to the c. All right, e to the c, we've talked about this, is 2.718, is e raised to some arbitrary constant, is some other constant. I'm going to put the constant in front, so it's going to be c times e to the kx equals, and that plus or minus y can be subsumed into that constant. Oh my goodness! So there it is. So my general solution to this differential equation is this. So here's my differential equation, and here was the general solution. And sure enough, as we suspected, the solution was an exponential function, and an exponential function with a base of e. This is interesting. Do you see where the k ended up? So when your differential equation had a constant of proportion there, it ended up in the exponent. So just think about why that makes sense, because it does make sense that that is so. All right. Hope you enjoyed that as much as I did.